which is Dr. Aaron Ault of Purdue University, and his talk is going to be on ag data sharing, conceptual tools in the technical toolbox, and implementation in the Open Ag Data Alliance framework.
Hi, everybody. Can you hear me okay?
Yes.
All right, and you can see my screen.
Correct. Yes, we can.
Excellent. All right, thanks for having me today. So my name is Aaron Ault. I want to also thank my co-authors, Servio Palacios and Professor John Evans at Purdue. So we're with the Open Ag Tech and Systems Center at Purdue University. And so just first, a little bit about me. Just so you know kind of where I'm coming from. I'm an active farmer, so I have about 3,000 head of beef cattle and about 3,200 acres of corn and soybeans, mostly pictured in that in that picture right there. I'm also a computer engineer, so I got my graduate degree in electrical and computer engineering, and co-founded the Open Ag Technology and Systems Center with a few folks at Purdue. And so OATS in general tries to sort of simplify making use of data on the ground in agriculture, but through what we say kind of enabling exponential commercial market growth by providing some open source framework level pieces of free code that other people can use essentially to help build the products and services that they use to serve to farmers. So we hit a lot of different areas from sensors and IoT all the way up to rural broadband communication, security, the cloud. We build apps, we do machine learning. We've got a really great group of people working in this right now. And as an open community, we're always looking for more folks that are interested in coding for ag. And so with the particular topic today on ag data sharing, I want to bring up a famous guy, Eric Evans, invented the domain-driven design movement in the software world. One of the most important things probably ever said by anyone is his quote right here from his domain-driven design book, that total unification of the domain model for a large system will not be feasible or cost-effective. What that means is even within a single enterprise, like just trying to solve the problems of one business, if you try to solve all their problems, you're not going to be successful. And if we want to look at data sharing across an industry of lots of those businesses, and we think that there's sort of one correct privacy model or one right model to do it, it's not going to work. And here's sort of fundamentally why he comes up with. So first of all, the idea is that we have bounded context. So if we want to solve a problem, let's look at the problem of just representing field boundaries on a farm, for example. The way you represent the field boundaries on your farm is different than the way a co-op represents it, which is different than the way the Farm Service Agency represents it. They each have their own uses. And by kind of bounding the context or the area that you're looking at to just one of these concerns, you inherently are going to have translation when you cross boundaries. So for example, if you're familiar with ag data, you know this grower farm field structure. It makes sense at the co-op level because a co-op has customers who are growers and they have farms and fields. But unfortunately, we have to use the same thing on the farm, and all of us farmers first say, well, who's the grower? Like, I'm always the grower. Why do I have to put that in? But a takeaway from this idea, though, is that your chance of success in your project is roughly, is inversely proportional to the area of the context you're trying to solve. Like if you can't draw a box around it, you probably can't build it. And that's why it's really important, I think, to understand the different technological tools that are at our disposal for designing these systems, because there fundamentally can't be one right one. There's going to be many models. They're all going to use different combinations of different tools. So I think it's important to understand what those are. So some simple ones to start with. Number one, just access types. Like at a cloud platform somewhere, someplace that has data, we can read, write, and then of course, admin is the third type that we typically have, which means we can assign read, write, and admin permissions to other people there. That one's easy. And right away, a really important distinction comes up here in that the data privacy guarantees we can make are all generally regarding read access. And there's a limit fundamentally to what kind of data privacy guarantees can be made from any technology. So for example, like Snapchat used to, made its way by creating an app that said that the person that you sent a picture to could only see it for 10 seconds. But of course, if that person just snapped a screenshot of their phone while it was on their phone, then they could see it forever. And so essentially, once read access has been granted to someone, that's the end of technological guarantees. And it's entirely a legal question at that point. And so I think it's important to make that distinction, that people understand that once you've given someone data, they have it, and you're just taking their word for it, what they do with it. So a second tool that we can have in here is user accounts and permissions. And this on its face seems simple, but it's helpful to understand that when we're talking about data sharing in an industry, it's between companies and within companies. So if I'm a user, I'm a farmer, I will have an account on multiple platforms. Each platform will have some representation of me, even though I'm the same person. And the sharing of things within that platform we would call permissions. So if I want another user on Google Drive to have read access to this document, I can do it. But if I want a user at Dropbox to have read access to my Google Drive stuff, that is not a question of permissions. That's something else, because you're crossing platform boundaries. And so one of our projects that we have out there, it's actually an open source implementation of a standardized API for data sharing. It's called the Open Ag Data Alliance. So I'm going to go through here a little bit and say kind of how these things have been implemented in that as well. So you can go get the code and download and run it yourself if you'd like to. But inside of there, we have this sort of intra-cloud read, write, admin, semantic. We have the concept of users, and users can assign permissions within one particular cloud overall. Now where it starts to get a little more complex is when we cross those platform boundaries, we introduce things called scopes and tokens. And so the way that this tool tends to work is you have a user like me that I have an account at two different places. I have a service that I want to do something for me, and I have a cloud that has my data. And so I would ask the service to do something, and then the service needs to go ask the cloud for what it needs to access. So it needs to say to the cloud, I want to access field boundaries. That ask, the thing it's trying to access, is known in the industry as scope. And so these scopes are a really important thing for an industry to understand, because it's something that the service is asking of the cloud without the user in the middle. And so what happens is when the service asks the cloud for field boundaries, they go back and ask the user, do you trust this guy with your field boundaries? And when he says yes, this cloud will authorize a token for the service, and then the token, or the service, every time it sends a request to do any read-write operations on behalf of the user, it's going to send that token along as its password. So any request that shows up at the destination with that thing on the request goes through as if the user themselves had made that request. So the service is acting on behalf of the user with this token. Now, in this flow, it's important to understand that this point right here is where the technological restrictions end, like as soon as he says yes, and the legal restrictions take over. So in OADA, we require that at this point is where the user is shown the privacy and use statement of the service that is asking for permission to view their data. And I think that's a really important piece. So within OADA, you've got scopes, and we also have the ability for a service that knew nothing about the cloud that it was going to be connected to actually request, to register itself and request access, and let the user kind of drive that instead of requiring or relying on the companies themselves to do it. And so the thing that we recommend be shown at that time when data sharing occurs is what we call privacy and use components. So since most people, when they get asked that question, they get a 50-page legal document that they don't read, we said perhaps and we also know there's no one-size-fits-all correct privacy, because different services do different things. In our opinion, the best thing that an industry can do is come up with a sort of standard set of characterizations. And at the time that data gets shared, the privacy and use statement a company can make is sort of checking the boxes of which of these characterizing statements describes what our service does. And then users can actually then decide, you know, in general, I don't like to do business with someone that shares identifiable data or something, and it becomes a much easier thing for them to figure out what they want. So we've got those published online as some suggestions. Tool number 4 we call shares. It's an odd thing, actually. If you've ever used Google Drive, you see this confusing thing on the side called shared with me, and you always wonder why you saw this document a while ago and now it's not there and you don't know where it went. Well, it's because it's under here and not under your drive. But the concept in general actually is on almost every system with permissions, the idea that one user can share something with another user. So in a sense, it's like this world writable place that one user owns, that other users have permission to add stuff to, but you can't really stop them from adding stuff. Like people can spam you. So anyways, in OADA, that is represented as a tree named shares, where applications in the API can actually access those things. Tool number 5, probably the most important tool I think in the tool belt, is how you organize data directly affects the ability of your users and your overall system to actually achieve certain privacy goals. So first, to understand how this data organization tends to work in APIs and across the web, is that APIs themselves identify resources with URLs. So behind the scenes, when you've got a web browser going and getting data from somewhere, it's typically using a URL like this to go find it. And if you analyze the last part of it, like you got a domain over here, the last part of it tends to look like a file system. In other words, a hierarchy, or in CS terms, a graph, a tree, a directed graph, something like this, that essentially is linking a folder named drive, and then there's a folder named u, and then there's a folder named 0, and so on. And if you're familiar with REST APIs at all, you may be familiar with these crazy things called query parameters, or if you've ever clicked on a link that had a whole bunch of junk at the end, and you wondered what it was. They call those query parameters. But of course, if you read REST, what we call RESTifarian literature, people who like REST APIs, you'll probably be aware that you can take any query parameter and just put it back before the end and put slashes in there, and you essentially can show that all URLs, no matter what query parameters you have, are fully reducible to a graph. So therefore, if you know how to organize your data sharing problem as a graph, then essentially you can do it over an API, and the OADA API, you kind of get that for free if you can figure out the graph. So from a simple perspective, if you imagine that like an agronomist has 3 different farmers that are sharing data with him, but they all happen to, and they all use Google Drive, and they all happen to use the same folders for storing their data. Like they have a fields folder and a harvest folder and a livestock folder and so on. Then that means his apps would know how to go find all the data that it needs. And so creating these standardized trees within different places is actually one of the core things you need to do to decide how you want to share data across different platforms. And of course, it gets tricky because that one graph structure has to fill a lot of roles. It has to be semantic, like organized by type of thing. It has to do sharing. It has to do indexing, which handles how we access small parts of a big data set. And then the hard stuff, streaming, concurrency, caching, all those kinds of things. So within OADA, we manage all those things by creating the concept of a single graph rooted at something called bookmarks for resource discovery. So if you have access to the user's bookmarks, you can use that graph to find the pieces of it that your application is looking for. Oops, sorry. Moving on, number 6, synchronization and caching. That for the most part, if the way that you get information in and out of your system is import-export, farmers are going to be really unhappy with it, and you have a very small market. It's sort of like the semantic of last resort. Slightly better is polling, where we can connect my thing up to your API, and I poll periodically, like once a day, to see if you have more data. A one-way push synchronization would mean that whenever you get something new, you're going to push it over to me, or at least push some indicator of it to me. One-way single master real-time sync means, though, that like as soon as it comes in on your side, you're going to exactly make a copy of it on my side. And then a two-way multi-master sync means that if the data can change on either side of the equation and it gets replicated on the other side automatically. And then the hardest one, actually known as the hardest problem in computer science, two-way multi-master offline first sync, meaning that I lost connection to the internet, but I still want to like be able to record information about my ag operation. And unfortunately, this is sort of the thing everyone wants, and it's also the hardest one to do. You can do these things with OADA, though. We can do polling, webhooks, WebSockets, and you can also do just a really simple automated one-way sync between, or two-way sync between 2 places by just making an API call. So that's nice. Then I have this one listed because every time you make an integration, this one comes up, and it is the most like it's the thing that stops you all the time. So I call it an anti-tool. Which is obfuscation, or in other words, if you have a proprietary API or you don't tell people and publish your data formats and your trees, like how your API is structured, you've effectively created something that can't achieve data privacy goals because nobody can get the data to move the way they want. So you have to have some level of agreement on how we authorize, find data, do reads and writes, request updates to data from the other side, negotiate our languages and formats, and alter permissions and things and so on. So this is one of the things that OADA provides as well. Oops. And then the last tool that I list here, cryptography. This is pretty important. That the two fundamental things cryptography tries to provide are integrity. So typically you see these called hashing functions. So the idea is I sent you a message and I also sent you a thing that if the message changed, you could tell that it changed. So integrity means I make sure that you received the right thing. And confidentiality means an attacker can't derive any useful information from the information they received, but you can still get it. And so as a corollary of a confidentiality, sort of you can prove you have the password that nobody else has, that gives you some level of identity as well. And so within OADA, we use this particular tool to maintain sets of trusted lists, like companies that are trusted to known to be identity providers. For example, you can do single sign-on. We also enable document integrity signatures and a couple cool features that we'll get into here if we have a little bit of time. So we take all those tools and we look at some design patterns that our team has actually used out in the wild with real ag data and across the food supply chain. Some of them come up like this one, for example, shared bookmarks. And so this is a model where you've got like 5 or 6 users. Let's say they're all users on the same farm. And we essentially have them as different users, but they're all updating the same fundamental backend. And so that becomes handy when you just don't want any kind of sharing complexity. To the system, we all are effectively the same user. So it's really easy when one employee on my farm marks a field as done. I see it show up on my phone and nobody had to do any special moving around. Another one is the domain admin. So if you're an enterprise user and you want to use OADA or Trellis to share documents with other companies, for example, one model you can use there is you have a sort of administrative user, and under that user's bookmarks tree are all the bookmarks trees of all the users that you want to be able to control. Another model is what I call a filtered graph. So you've got some data in a graph and it doesn't match the sharing that you want to do very well. For example, the graph perhaps doesn't have the year that the harvest was done, let's say, and you want to share only 2018's harvest data with someone, but it's not in a folder named 2018 in layman's terms. So in that way, you just need to create these one-way single master synchronization microservices that essentially take just the pieces you're allowed to share and make a copy of it and share that thing instead, but it keeps them in lockstep with each other. Another model that we have is the Crossroads OADA sync. And so that's one where the user themselves has a cloud that they like to think of as like the place I store my data. If it's OADA conformant, for example, they would configure all the sources of data to push stuff into whatever cloud they chose. Sometimes it's 2-3 hops through different clouds. And then that cloud's job is to essentially push it back out to all the other places they want to connect it to. We call that the smusher within OADA, that it smushes data around to different platforms on behalf of the user. Another one is mask and link. This is actually a piece of open source code you can go run right now, which can watch for any incoming data into your platform and create what we call a masked copy of it. So it will remove all the personally identifiable information that it finds according to rules, and it will create a new version of the document with all of that stuff sort of, you can imagine it's like blacked out by the secret guy at the CIA that he just has a lot of Sharpie markers and marks over all those documents. It's sort of marking that out digitally, including, however, a hash and a pointer back to where if you have permission, you can go see that data and audit it and make sure that it is what you said it was, but you didn't have to push any of that sensitive information outside of your own company's boundaries. And then lastly, my particular favorite, we call it AGAPE cert. AGAPE stands for auditable, generalizable, automated privacy enabling certifications. So in other words, we can actually, because we have a standardized API, we can actually ship the code that had privacy concerns to the data and let the user run that on their own private data and then take the resulting certification and ship that back out. And then you have guarantees that the code ran the way it was supposed to, but you never had to ask anybody to share their private data with you. So those are some of the design patterns we've had overall. So I can take some questions now.
Excellent.
Okay. First question, how is technology transforming the scope of the challenges that we can address? In other words, the boundaries of what we could describe are probably changing based on the technological advances.
Yeah, that's a good question. That is very true. I can sense a whole lot more things today than we could have 10 years ago. I also have much more ubiquitous, 4G cell service than what we used to have. It's not everywhere, but it does exist. I've got on my farm. So we can push a whole lot more through the pipes. We can create a whole lot more data on the front end. And of course, more data, it's kind of like when we moved from, subsistence farming through the Industrial Revolution, that we essentially diluted the farmer's attention across ever more acres. We have the same problem here, that we have a significant amount of data to handle, and so we need much more automation in those systems. And so that's where I think these tools become really important, because we need to have systems that we can trust to do stuff for us without us having to actually handhold them all the time.
Good, yeah. Another question. Given what you said about where the technological limit to protection stops, what would the advantages be of using these approaches, or OADA specifically, over other systems?
That's a really good question. So it's too long of an answer maybe for what we have here. I'll give you an example though. Mask and link, for example, because once someone has the bit, then you just have to trust them to do the right thing with that bit. Mask and link says, I don't have to give you the bit. I can give you a thing that represents the bit that you can't reverse engineer, and then I can control access to your stuff. So for example, if you push something into a blockchain, it's public information to everybody on that blockchain. And so you think, okay, I'll encrypt it. Well, if you encrypt the thing and put it on the blockchain, it's there forever. No one ever deletes it. It's immutable. It can't be deleted. And that means you have a huge time-based attack vector for a malicious user to just like find one of your disgruntled employees and get the decryption key and access it. Versus mask and link, where essentially you say, I'm going to push up to a blockchain a masked copy of the stuff, meaning that people that I want to approve can get it, but I can shut that access off at any time that I want to. So that's some examples of where I think having this model gives you a whole lot more tools than you would have otherwise.
Cool. Thank you.
I think we got time for one more question.
But I don't have another question. Sorry.
Okay. Well, I think, thank you, Aaron. Appreciate it.